Okay, we're going to learn now how to compute Spearman's rank order correlation coefficient as our first measure of association between ordinal variables. When data are ordinal, the value of the coefficient is still going to range from -1 to +1. And the formula for the equation is listed here for you. I'm not going to go over in great detail the components of that because it is very well detailed in the Revel text. What I'll tell you is that the Spearman's rank order correlation coefficient is that R sub s. The D refers to the difference in rank between the x and y variables, and that's very well explained in the textbook. And N refers to the total number of cases. Now here's an example that comes straight from the book. We have table 12.1, which is a socioeconomic rank and status on the internet rank. And here these are just listed from socioeconomic rank. Max has the highest socioeconomic status and Steve has the lowest socioeconomic status. And then the status on the internet, Flory is first and Linda is second. So all of these individuals have been ranked on these two variables. Now, the difference between the two ranks here is the difference between x and y. So I can see here that 1 minus 2 is -1, and then when I square that, then it comes up with 1. And so I do that for each one of these. And what I endeavor to do overall is to sum the square of the deviation scores. And so I have a sum of squared deviations of 10. And so again, these refer to socioeconomic status rank. This refers to time spent on the internet rank. I can see that Max is number 1 for socioeconomic status, but number 2 for time spent on the internet. Once I subtract x from y, I get -1. And I do that all throughout these columns. Now, sometimes observations are tied for ranked position. This is articulated and demonstrated in table 12.1.1. What we do in this case is I sum the tied ranks and divide by the number of tied cases, and then I proceed as I have done before by taking the difference between the rankings across x and y variables, squaring them, and then summing the squares. So table 12.4 and table 12.5 provide a discussion of how to do this. Once I do this, for example, I can see that IQ, okay, this is table 12.4, I can see that IQ, here are the scores, and here are my ranks. So I have, for example, IQ of Kumiko here has an IQ of 140. That's the highest IQ, but Corey also has an IQ of 140. And so even though I have to put these in sequential order, I put 1 and 2, but I have to take into consideration that these are tied. Likewise here, 2 at 110 is also a tie, and I have a tie up here as well. So this is 5, 6, and 7. So we need to figure out how to rank these so that we can create our different scores. And by the process that is listed in a couple of slides previous, we can develop a kind of tied rank score, where here I can have these are tied for first and second place. Here I have 3 that are tied for the 6th position. And then once I have that, I can still compute my deviation scores and then my squared deviation scores. Now, when I want to test the significance of the rank order correlation coefficient, I need to ask whether or not my sample size is less than or equal to 30, or whether or not it's greater than 30. If it's less than or equal to 30, then I can compare the calculated coefficient with the value in table 1 in Appendix C. And if it's greater than 30, then I can convert it to a raw score, okay, or a standardized score with the following formula, where I take the value for the Spearman coefficient and multiply it by the square root of n minus 1.